In this video, we'll be talking about fundamental introduction to the stats class, and also we'll be covering some of the content in the research methods class. Our focus will be the types of variables, levels of measurement, and because these are the key to the later data analysis or any other descriptive stats. So let's begin with why statistics are so important. It is important. The whole thing is important because we want to call ourselves science. As you want to be a science, you need something to prove, and you need most likely those numbers to convince people that something is working or something is not working. It's really important that you show those numbers to the people. You show those tests we will be covering later to people that your research is solid. And another important thing is that we want everything can be replicated. Methods and the stats are really important even in the social sciences. And also in particular criminology and criminal justice field, we can also use the stats to test theories. Okay, we have tons of theory, rational choice theory, social disorganization theory. We have all kinds of the criminological theories, and we want to know whether they are correct or whether they are not. So the purpose, there are many purposes. We just covered some of the purpose in the previous statements, but the most important thing is we want to generalize those information from a sample to a population. Again, some of the content are coming from the method class, so I just going to briefly refresh the memory. Okay, refresh your memory. So we have population is an entire set of people, places, objects that a researcher wants to study. It doesn't have to be only the people. It could be the place, it could be the country, it could be the state. It could be a particular population, or even it could be some kind of cases, right? But in reality, the problem with the population or the problem with study on population, based on population, is that we can't, most likely we can't study everything in this population. So for example, the US has about 300 million population, and if you wanted to study what's their attitudes toward death penalty, there's no way you can survey 300 million people and within a reasonable time. So that's why we need samples. The samples are basically coming from the population, and when we do the sample selection, we want to make sure that the sample share the similar traits as the population. So the samples could be a good representative of population. So we have some national survey or national data within the criminology, and the two of them are really popular and famous. The first one is the Uniform Crime Reports, the UCR. UCR is maintained by the FBI, but in theory, local police department will upload their data to the FBI database, and from there they collect those data and report based on those 8 index offenses. And you can see it covers 8 index offenses such as homicide, rape, robbery. So it does not really cover every crime. Okay, it covers some part of the crime. We have lots of the crimes that is not being covered in the UCR. And also another weakness for the UCR, although it's a kind of a national data, another issue with it is that it comes to all the crimes that gets attention from the police can get into the UCR. Again, we talk about this is uploaded by the local police department. So the police department should have the data first, then they can upload it. So if a crime that has never been reported to the police don't know about the crime, then the UCR definitely doesn't know the crime. So on the other side, we can collect data from the victim side. okay, which is the second most popular and famous national data called the National Crime Victimization Survey, NCVS. This one is basically collecting data from the victim side. Okay, it uses a multi-stage cluster sampling to survey the people in selected households. So the problem with the NCVS is that it basically every results, every case is depending upon the victim's memory. And as we know that human memories most likely are not so reliable like a computer or something else, right? There are so many factors that can impact our memory. So the data coming to the NCVS may be slightly different from whatever actually happened. But the good thing is that it's from the victim side. So combining with the UCR, we most likely have two national data set about the crime criminology. One is from the police side or the offender side. Another one is from the victim side. Now we will briefly talk about how do we obtain the sample, because those information or those concepts are basically discussed in the research method class. So we have probability sampling methods. The most likely you will see or the most or the best one you will see in probability sampling is a simple random sampling, right? I have a population of about 10,000 people, so I randomly pick up 100 people from 10,000 people to make our sample. We also have other ways like systematic, stratified, multi-stage cluster sampling, or those are based on the probability. That's why they call the probability sampling. Okay, we're not going to too deep about how to do those things. We also have the non-probability sampling. This is often quite you will see from like qualitative research, like in the interview or like a focus group. Um, the classic example will be like a purposive sampling and snowball sampling. So basically, it's those samples are um, from the person who are willing to join the study. And the snowball sampling basically means like you can talk to one person and this person knows other two persons. Those other two persons may want to join the study and they also know other 3, 4 persons. So it's like making a snowball getting more and more big. But as you can see, these are non-probability sampling methods. That basically means these are not based on the mathematical way. So the samples could be biased, right? Because only the people who want to do or participate in this study will be in this sample. But most likely, for some of the cases, purposive sampling or the snowball sampling are the only way maybe we can do to conduct our research. So, and those are the most likely to be used in the qualitative research. So there's no such a good thing or absolutely correct way that we do the sampling. It's just like you have to pick the most fit sampling methods. Okay. So let's go back to some very basic terms and concepts in the science. So the science is a process of gathering information, developing knowledge that are accepted by other scientists in the discipline. That's the first thing we talk about at the beginning of these slides, is that you want to show people that you have something. And most likely, nowadays, people are more likely to believe in numbers, in stats, in those p-values, or even like just numbers. Okay, so the way that we do, or the methods that we do science, we conduct science, is that we have some procedures that can help us to get scientific results. Later, we will talk about different methods or different statistical approaches to analyze data. Those are considered as a scientific way to obtain scientific results. And also in paper, in most likely in academic paper, you will see is that most of the authors will disclose their methods and how they code them, how they code the data, how they get the data, sort of that things. So other people can take a look at whether they're doing it correctly or not, and also other people can replicate if they want, replicate the study if they want. Okay, replication is one of the key things that in the in the methods and in the stats and also in the social science. And I think in the natural science as well, like you want your results, your research result can be replicated in different places. Let's say there is a program locally that can reduce the crime by 20%. Now we know that this program may work in another location or may not work in another location. That's the thing we wanted to know. Okay, so we want to replicate the similar evaluation study in another location to see if this program can reduce the crime rate in that location as well. Okay, so we also use the stats or statistical analysis to finish our theory testing or conduct our theory testing. The theories is a proposed explanations of certain events. It's like a big thing that can cover or explain some little things. Okay, like a rational choice theory, like why some people choose to commit crime when some other people don't. Okay, some people are rational, some people are not, and some people are when they choose to commit crime, it must be the benefit is significantly more than the cost, right? You will be evaluating the benefit and the cost to make sure that you gain something from these criminal activities. Otherwise, you won't do it, right? Otherwise, the thing you face is a punishment, so you don't do it. And we also have other theories like routine activity theories. It basically talk about motivated offenders, suitable targets, lack of guardianship. Can be gathered together in one location at one time. If so, then there is a high likelihood that some kind of crime will happen there. Okay. However, the problem with the theories is that most of the theories is super big, especially in the social sciences. Those are super big and it has multiple components. So we make most of the time the data or the some of the data we get cannot test a whole theory. So what do we do? In practice is that we cut the theory into pieces, we make them into the hypothesis. That's why later when we're going to talk about hypothesis tests, it's like a part of the theory. Those arguments, those hypotheses are part of the big theories. Okay, so if we cannot test a theory because it is too big, too broad, then we cut it into the pieces and make hypotheses. So we test out the hypothesis. So for example, the theory can be cut into like 3 pieces. We test the first 2, prove it's working or they are working, and we test the third one. It found out not really. So we can like remove the third one from the theory, or we can like revise our theory based on the results from the third test. So it's all possible. Okay, but that's the way we do. And in social sciences, or particularly in criminal justice, we broadly and briefly, we can divide our research type into descriptive, exploratory, and evaluation research. Descriptive research is super simple. It's just like describe something, okay? Describe a phenomenon, describe a subject, describe like criminal activities. The exploratory research is the one to interpret why people commit crime, why people don't commit crime, why people report a crime to the police when some other people don't report a crime. Okay, it has to figure out like, okay, why we doing this one? Okay, it answer the big question of why. The evaluation research is most likely related to like the programs and the policies. Okay, we want to see if the program works or not, or if we want to see if the policy works or not. So we will invest a small money into a small evaluation research, and when it comes out with like a positive results, then we may investigate more money into this one, make the program bigger, or introduce the program into to another places that may working. Okay, evaluation research is really important, especially in the social sciences, because it guides out where our money should be putting at. Right? Imagine like you have a nice program that can reduce the crime rate, but you don't have the money. Or if you have some kind of money and you don't want to waste them, some kind of funding, you don't want to waste them, you definitely want to investigate your money into those programs that works, right? So we are going to move into the still those are the information most likely you get from the methods class, but again for the stats class these are very fundamental concepts that you need to know before you can run any kind of data analysis or descriptive statistics, variables and levels measurement. Okay, variable. A variable is a one that can describe a people, objects, places, or any kind of things in a population or in a sample that has multiple values that has a multiple values. Okay, the constant, in other words, is that we call them constant, but most likely the complete term is a constant variable. Is a variable that only has a one value in a sample or population. Now, make sure that you see this one variable and constant. Most likely you will see in a population or in a sample. Okay, so it's not really working on a particular case. So for me, right, for me, you can say my gender, I'm a male, so you can say my gender is a constant, but who knows, someday I will decide to be a lady. Okay, so my gender could be a constant for now, but it could be a variable in the future because I could change from a man to a woman, right? But however, at one moment, my gender is always set in the one value. Okay, at one moment, at one time, my gender is always set at one value. Okay, either I'm a male or female or other kind of a gender. Okay, it definitely going to stay one value. Okay, so it's kind of not so meaningful to say variable or constant just based on a single case, a single person, a single location, a single subject. Usually we use a variable and constant in a sample or a population. Okay, now why this concept is so important? Because when we try to make a comparison, we must control all variables except the variable we want to study. Okay, let's say you wanna compare like a people or the male inmates and the female inmates who spend more time in the prison. Now, it could be overall look like male inmates are spending more time in the prison than female inmates. But the problem with that is that the male inmates are more likely to commit a violent crime, and usually the violent crime actually, put people behind the bars longer than like just a theft or other minor crimes, right? So when we want to see a solo variable, whether it has influence on another variable like the gender, on the length of incarceration, we have to control the other thing. We have to control the crime. So let's say we want to compare the male inmates who commit, let's say, who commit theft, and compared to the female inmates who commit theft as well, and to see if the male inmates spend longer in the prison or the female inmates spend longer in the prison. Okay. Now we have other variables that may impact the length of incarceration. For example, we may also have the criminal history, right? So we expand the previous sentences will be like we are looking at a male inmates who had three crime in the past, and now he's in the prison because of robbery. And we want to compare this male inmate to another female inmate who also have three crime history, and who also is currently incarcerated in the prison because of robbery. Okay, so you have to control other variables except the variable you want to study, except the variable you wanted to use to interpret something. So the example for here is like compared to males, females are more likely to be crime victims, right? So the variable will be the gender, as here we can see the variable has a male, female. And also the variable could be likelihood of being victims, high likelihood, low likelihood, right? And also the constant thing, again, we are going to study the gender's impact on the likelihood of being victims. So we have to control other variables such as the crime type, race, age, educational level, or family income, marriage status, or even like where do they live, right? So community status, or what do we call them, the social status. Okay, these are the ones that also can be impacting the likelihood of being victims. So when we only need to compare male and female based on the gender, then we have to control other variables. At this moment, other variables are becoming constant variables. We also have the dependent variable, independent variable. You have heard of this numerous times. The dependent variables is the one that researchers want to study, explain, predict, whatever you call it. Well, actually explain or predict are having differences and big differences, but in this video, we are not going to distinguish them that much clear, okay? And in the independent variable is a factor or variables that used to try to explain or predict a dependent variable. So in a mathematical way, most likely in the formula, for example, y equals to x plus 3, and you can see we always use this one as a classic example to interpret dependent variable, independent variable, variables, and also constant variables. So here you can see we have the dependent variable is the y, independent variable is the x, because we are using the x to predict the y, right? If the x equals to 1, the y equals to 4. If the x equals to 5, the y equals to 8. Well, as you see, like now you can say like, oh, why we can't use the y to predict the x? Yeah, but it does make, it's the same thing, okay? And here in this formula, we have one constant is a 3, because whether you change the values of x into any kind of values, plus 3 or 3 is a constant, is that it never goes. It never changes, right? So why this is important, dependent variable and independent variable, because it helps us find out what is going to be predict or what is going to be explained, and what are the variables that we use to make such a prediction or explanation. So for example, compared to males, females are more likely to be crime victims. We talked about in the past example, right? We have the dependent variable, likelihood of being victims. We have independent variable is gender. Again, in this statement, you are looking at the gender's impact on crime victims or the likelihood of being victims, not the opposite side, opposite direction, right? You're particularly looking at the gender's impact on likelihood of being victims. So here, gender becomes the independent variables, and the likelihood of being victim become the dependent variables. And again, we have to control other variables that may impact likelihood of being victims as well, such as a crime type, race, age, educational level, social status, some kind of other things, right? So some of the practice, now you can pause this video at any time and as a practice, okay? Compared to the boys, girls are more likely to be the victim of sex crimes. Now the dependent variable is easy because we are looking at the likelihood of being victims of sex crimes, right? Independent variable, boys, girls, these are like can be covered or can be indicated by gender. So the independent variable will be the gender. The dependent variable will be the likelihood of being victims of sex crimes. We also have another one. Carrying concealed guns can reduce the likelihood of being robbed. Okay, easy one. The independent variable is whether a person carries concealed guns or not, or whether carrying concealed guns or not. The dependent variable will be the likelihood of being robbed. Okay, again, here, those are the other statements, those are the hypotheses, those are basically some kind of a statement that at this moment we don't care about those statements are right or wrong. So for example, like people say, well, you carry concealed guns cannot reduce the likelihood of being robbed. We don't care about this one at this moment. Okay, we care about what is an independent variable, what is a dependent variable. The unit analysis is the object or target of the research study. Okay, in social science, most likely unit analysis will be like individuals, but also it could be like prisons, incidents, records, groups, cities, states, even countries. All kinds of things can be unit analysis. Okay, the unit analysis is important because it can help us to know when or where, what and where we can get the data, and also how we interpret the data. Okay, so for example, if the unit analysis is individual, we are going to interview and survey individuals, right? You are, let's say you want to know people's attitude toward the death penalty in American. Now the problem with that, to like look at the state status or county status or city status, is that they don't have this information, right? You are looking at the individual's attitude toward the death penalty, so you are going to ask individuals, persons, right? So, but if the unit analysis is a case, we are going to find the case. So, for example, you are interested in um, like the cases who where the offenders are sentenced to death penalty. Then you are going to look at the case. Most likely will be like a first degree murder, something like that. Then you are going to looking at those cases rather than just the individuals. Okay, and for example, like UCR, NCBS, we just talked about like 20 minutes ago. These are the one that unit analysis will be the cases in data analysis. Okay, we are not really talking about where we get the data, because when we collect data for NCBS, UCR, it might be from the individuals, right? From the victims, from the police. But the thing is, like when we're going to run the data analysis, the unit analysis could be the cases, because information in the UCR, NCBS are is represented by cases. Okay, so what unit analysis is really depends on what the question you ask. You could ask the similar questions and you have completely different unit analysis. So in the first statement, do people who have guns in their home feel more safe than people who do not have guns in their home? So in this way, or if you ask questions like this one, you put this as a research question, you will see like what you do is you are going to interview the people who may have the guns, and you are going to compare this one to the people who don't have the guns in their home, right? Ask those questions. So unit analysis will be the individuals. However, if you ask questions like, are people who have guns in their home less likely to be victimized by burglars than people who do not have guns in their home? Now, at this moment, it's really hard to just interview the peoples, because you can't really easily find the people who have guns and being uh, burglarized, or people who don't have the guns being burglarized, right? So the most convenient way is that you may go into take a look at the local police records, or maybe from the NCVS, that you will know. Um, so you can find the data. Okay, it's really, really important that we understand the unit analysis is, because this is where we can get the data. But these are very basic. Methods class should talk about all the things. Level of measurement, the second most focus, or the second big thing in this PowerPoint is the level of measurement, right? So every variable will have a level of measurement, whether it's high or whether it's low, it's a high level of measurement, it will have that one. Okay, level of measurement is a way of classifying, describing variable types. Now we have two big categories. One is the categorical variables, and the second one is the continuous variables. Okay, and also each of them have two subgroups. So in the categorical variable, we have the nominal variables, and we also have the ordinal variables. In the continuous variable, we have the interval variables and the ratio variables. Now, this is a methods concept, but we will talk about this a little bit in details. Okay. So the categorical variable are the variables that has the names. Okay. And most likely, if it's a nominal variable, it means that this variable will only has the name. It cannot be ranked based on this variable. Okay, so for example, your name, my name, those we are having the names, but you can't rank maybe like Abby higher than Ashley, or you can't really rank like Michael higher than Jason. Okay, it doesn't really make any sense when you're going to make those rank. So the names of each person, or even the animals, or even objects, these are most likely will be the nominal variables. Okay, so for example, like a race, white, black, Asian, these are the names. You can't say white is higher than black or black is higher than white, right? So the race is also like a nominal variable that cannot be ranked. The ordinal variable is a little bit higher level of measurement. Is that it has a name, but somehow it also can be ranked. Okay, so the ordinal variable, we will see some of the example later. Okay, it has a name, it can be ranked, but the rank is really based on the name instead of based on like the numbers. So continuous variables are the one that made of the numbers, most likely. Okay, when we're talking about continuous variable, what people usually think about is the numbers. Okay, and indeed, these variables are most likely to be um, measured by numbers, not 100% times, but 99.9% chance. Okay, so there are two types in continuous variable. One is an interval variable. The interval variable is it basically is a number, but it does not have a true 0 point. That's a difference between the ratio variable. The ratio variable has everything and also has a true 0 point. Okay, we will interpret this a little bit later. So here, this is the levels of measurement and how you decide which one is which variable is what kind of a level of measurement. Okay, so for example, every level of measurement, every variable should have the name, right? Every variable should have the name. If the variable can be ordered that it goes up one step up, could it become an ordinal? Okay. Now, if the 2 points in this variable, the distance is meaningful, then it goes to the interval. And if it has a true 0 or absolute 0, it goes to become the ratio. Okay. It's like a one step up, something like that. So at this moment, you may be a little bit confused, like what is the distance meaningful means, okay, and what is absolute 0. So we will show you some of the example in a few slides. Okay, so most likely the way that you categorize a variable into like categorical or continuous variable, whether they are nominal, ordinal, interval, ratio, you can follow this like the steps. For example, does the variable have name? Every variable has a name. So yes. Can it be ranked? No. If it cannot be ranked, it goes to the nominal variable. Can it be ranked? Yes. Goes to next question. The distance between 2 points of variable is meaningful. 1, 2, the distance is 1. 2, 3, the distance is 1. That's meaningful. You win the first prize and somebody wins the second prize. That's a little bit different, right? And you feel the weather is hot. Another people feel the weather is hotter. Well, the distance between hot and hotter, not so meaningful, right? You can't really represent the numbers, use numbers to represent hot and hotter because it really depends on the people's feeling. Some people think 100 degree is hot, when some other people think 110 degree is hot, right? So it's different. So if the distance is meaningful, or if the distance is not meaningful, then it will be an ordinal variable. But if the distance is meaningful, then it could be having a zero or absolute zero. It could be have no zero. If there is no absolute zero, then it will be the interval variable. And finally, we have the ratio. Ratio is the highest. A ratio is the best. If you can get the data, get the variable as a ratio variable, then go for it. Okay. Now, here are some examples. Okay, here are some examples that to decide whether some variable is nominal, ordinal, interval, ratio. Now, you can pause a video and spend maybe a minute to check whether those variables on the left side, whether they are nominal, ordinal, interval, ratio, and we will talk about this in the next. Okay. The first thing, sex. Sex is nominal, male, female, even more genders. Okay, it also only has a name. It cannot be ranked, so it stops at the nominal. Height and weight, they're racial, right? Height and weight, it has everything like names. It can be ranked. I'm taller than you, right? It's a ranked, and also it has a meaningful distance. For example, I'm like 1 inch shorter than the other people, so the other people is 1 inch higher than me, so it all doesn't make sense, right? And also height and weight has a true zero. So what's the zero weight means? That means there's no weight, right? What's the zero height means? That means there's no height. Well, in reality, it could not be um, achieved, but in theory, there is something like that, right? So the weight and height are racial variables. Year of birth, 1997, 2010, 2001. These are the interval variables. It has a name. It can be ranked, right? I'm older than you. I was born 1 year earlier than you, right? It can be ranked. And interval because it doesn't really have a true zero. So year of birth, zero. What does that mean? Is that means the year you don't you were not born, or is that the year like the beginning of the our world, right? So you don't know, and it's not really about you don't know. It's about its meaningless. Okay, so it is interval variable. We have age. Age is a racial variable. Okay, it represents by numbers. And most likely, like age 0 basically means that you are not born yet, but you are close to born, but you were not born. Types of fruit: strawberry, apple, watermelon, or grapes. Those are the fruits. They only have the names. You cannot really rank the fruit better than some fruits are better than other fruits. Apple is better than banana. Well, if you're looking at a particular nutrition, that may be true, but as a fruit itself, or as a fruit as a set of the thing or object, you can't really say apple is better than bananas, or bananas are better than let's say pineapple or something like that. Okay, you can't really say. Temperature, that's the one people usually got a little bit confused, is that I always think the temperature is an interval variable when other people think the temperature is a racial variable. So basically what I see the temperature as an interval variable because the temperature has a kind of not so meaningful zero, right? So if the temperature has a zero, a meaningful zero basically means there is nothing. Okay, the zero height, zero weight means there is no height, there is no weight. And zero temperature, that means there is no temperature. Physics told us no, everything has a temperature, even it's really, really, really low, even if it goes to the negative 273.15, there is a temperature. Okay, if there's no temperature, no atoms will ever moving, or something like that. I'm not an expert in the physics, but in my view, the temperature will be the internal variable. Some people think that the temperature is a racial variable. I would, respect that. But I think it's an interval variable. Okay, so the race we mentioned about, race is a nominal variable. You can't really say white is good or is better than black, or black is better than white. So it just has a name. It cannot be ranked, right? So degree of like, so very like, okay, dislike. Now this is most likely to be ordinal variable because you can actually rank them based on whether you like it or how you like it, very like, okay, or dislike. Or on the other direction, dislike, okay, very like, right? It's ordinal. But the distance sort of not meaningful. So the distance between very like and okay, is that the same distance between the okay and dislike? It's really hard to say. Okay, so in theory, such things um, are such variables are considered to be the ordinal variables. However, in most of the practice that we use the degree of like, and when we're going to code them, I can write something here. If we use that, we're going to code them like a very like as very like as a 3 points, okay as a 2 points, and dislike as a 1 point. So in practice, we may do something like that. That will transfer the ordinal variable into a racial variable in practice when we're going to run the data analysis. Okay, it's not a theoretically 100% correct way to do that, but again, it is a maybe the most proper way to do that. Okay, so as I mentioned at the beginning, there is no perfect. The only thing we can get is a better or the best choice. Okay, there is no perfect choice in social sciences to do data analysis like that. Okay, so again, for variables like degree of like, in theory, it will be recognized as an ordinal variable. In practice, we usually use a racial variable and give them the numbers like 3 to 1 or 3 to 5 or 1 to 10, something like that. Not 3 to 5, 1 to 3 or 1 to 10, something like that. So they become the racial variables. So why this is important? Because if the more information available, the more ways that you can compare the cases. You have more ways or more statistical analysis can be done with the quantitative data than the qualitative data. Okay, so this is listed like how things goes to like for the first two, these two are the categorical data. You can't run any mathematical things to do that. Okay, so you say my name add your name. What's that? It doesn't make sense, right? Uh, like a race white add black or black add black equals two blacks. But it doesn't make any sense. In technically, you can't really explain something like that, right? But when you're going to add a ratio or the interval, most likely the ratio variable, right? The ratio variable 1 to 5, you add them, right? 1 plus 2 equals 3. Those are the most meaningful thing. So these are the one that we can actually run. And this is the most reason that we, as I mentioned before, that if you can get a variable as a high as a ratio, then go for it. Okay. So for example, if you describe temperature, the difference between 10 degree and 25 degree is a difference of about 15 degree, right? So it's a 15 degree should be the same as a difference between 60 degree and 75 degree. It's also like a 15 degrees, right? So it could be the same. But however, there is no mathematical sense in the statement that 80 degree is twice as hot as 40 degrees. So you never say people say as twice as hot or as twice as cold as 40 degrees, something like that. It doesn't really make sense, right? So that's why this is another reason I think the temperature is a interval variable instead of it's a ratio variable. Okay, because it can do this one or can do division. Now, like I said, the best way to use is to use the highest level as possible. Okay, for example, if you have a survey asking people's age, so make sure that you want them to write down their actual age, like 1, 2, 3, 4, 5. These are what we call the continuous variables, right? Racial variables. Rather than give them the choices like, what's your age? 1 to 9, 10 to 19, 20 to 29. So a person select this group, 20 to 29, and a person select this group, 30 to 39, and a person C select 10 to 19. Okay, as you can see now, it goes to become from this one is a continuous variable, 1, 2, 3, 4 racial variable, from a good one into like a simple ordinal variable, right? Ordinal variable, because the distance between C and A and the distance between A and B could be different, because for example, C could be like 11 when A is like 21, right? And B is like 38. So you can see the distance between C and A is like 10. And the distance between A and B is like 17. They don't have the same distance, right? So, and if you can switch like A could become like 23. Okay, the distance is 12, the distance is 15, it's still not match. So it's really, really important to understand that when you're going to collect data, such as like age, or any other things that can be represented by a racial variable, go for it. You have to use a racial variable to represent it. Okay. And again, another reason is that a continuous variable like a racial variable can be made categorical later, but a categorical variable can never be made continuous. A good example here is like we have 1, 2, 3, 4, 5, 6, 7 people. Okay, Wendy, Daniel, Michael, Tony, Lily, John, Emily. Okay, so their age is measured by these numbers, and we know these numbers are continuous numbers, which is good, right? These are racial numbers. So if we say, okay, now let's group them based on their original age. So you will see like Wendy goes to the group 2, Daniel goes to the group 1, Michael goes to the group 2, Tony goes to 4, blah, blah, blah. But the question is, this way, you can down this way easily, right? But can you go back? So if, for example, if I telling you Wendy is in the group 2, and the group 2 is 10 to 19, so can you go back to and guess Wendy's age is 19? Well, you could. But you can also guess Wendy's age is 10 or 11 or 12, right? So you don't know. The similar happened to not Michael, like Tony. Tony is in the group 4. So if I say, can you tell me what's the actual age of the Tony? And group 4 is from 30 to 39. You have to pick. You have to guess, right? So you can get like 30, 31, 32, 33, and Tony's actual age is 35. So the thing is that a continuous variable that can be made categorical later, but the categorical variable can never be made continuous. This is a good example. Okay. Now, in practice we don't really see quite often that categorized continuous variable, but the possibility is there, which basically means we can do that, but we don't have to. Okay. However, if you already or at the beginning you collect their age as a group, then it's really, really hard to go back to see their own age and as a racial variable. So in reality, or in practice, interval racial variables are interchangeable. Or continuous variables. So in reality, most likely we divide a thing into categorical variable or continuous variable. Or so we don't really go that much deep, like whether they are nominal, interval, ordinal, or racial. Okay, we most likely in the stats we want to distinguish them from categorical variable or continuous variable. This matters in the stats. Okay, so and also variables created by scales are often treated as a continuous variable. For example, the previously I say like a like, okay, dislike, sort of like that. But also like this one, like strongly agree, neutral. disagree, strongly disagree. So again, in theory, this is a ordinal variable, okay? Because you can't say strongly agree and agree the distance between them, those two, are the same as the distance between edge and neutral. You can't say that in theory. However, in practice, we use like numbers to modify it. So like strongly agree, we give them 5 points, agree give them 4 points, neutral 3 points, disagree 2 points, and strongly disagree like 1 point. So we make this one Likert scale into a continuous variable. This is in practice. Okay, but you will see. You should remember that in theory, these are just ordinal variables. They can only be ranked, not having the same distance. So here is a summary, like what do we want to know? So determine whether the variable is categorical or variable or continuous variable. If the variable is categorical, whether it is a nominal or ordinal, if it's a continuous, whether it is an interval or ratio, and then think about what we can do or what mathematical way we can do to those variables. Okay, that's it.